Hello, everyone. I had a little bit of lunch, had a chance to rest a little bit, and now I'm back at it. So I thought I would do another live stream, continue giving you guys the chance to join in and ask questions if you have any. Feel free to ask questions, interrupt me. If I'm busy, I'll get to your questions as soon as I get a chance to read them. Hi, guys. Mark, you are crazy. Oh my goodness. You're gonna kill yourself, you know. Only I can do things this taxing to the soul. Welcome back. I keep trying to use my variables, but they're not available in here. Wow, okay, that is not what I thought. There we go. Hmm. Hey, Christoph. No, I don't want to dare put a crowdfunding page up right now until I'm sure that I have a product that's going to perform for you guys. So, I was sick for the past 2 weeks and apologize that I haven't gotten anything more done than I have, but I'm back at it now. I'm feeling better. So, I'm not going to be one of those not going to be one of those Kickstarters that fires up a Kickstarter page, gets a whole bunch of people excited, and then realizes that I can't deliver on the end product. So that's my my I don't know, strategy. Frederick, holy cow, you're back. You're a machine, buddy.
Hi,
So
Frederick.
my wife says hello. All right, why does it not like that? Hmm. It wants to move on the Z. Okay. So fine. Christoph, yeah, that is what the point will be. When I finally have a product that is ready to rock and roll, that's when I plan on showing it to the group and putting it out there. Bless you.
Excuse me.
Bless you.
Sorry.
Damn coronavirus.
You'd be coughing, not sneezing.
Mark said it sounds like it. All right. Okay. Let's see how that works. That's looking better. A variable vertical axis wind turbine, VVWAT. I like it, Frederick. Speak speak to those advantages a little bit more. I do like the sound of that. All right. Yeah, if I could do a linear pattern, it would be interesting. Because I could close everything up together, but this little test unit's not going to be able to do that. And I'm not sure if I like the fact that you would have to use these sliders. I don't know. What do you guys think? It's going to allow the little test unit to have some really different characteristics than the full-sized unit, because you could have the scoops open at different angles, which, you know, really that's not going to be allowed in the full-sized unit. But unless I have a full set of gears going through everything, which is impractical in the little tiny model, then, you know, you can't really do that. It's funny, this one is created with the helix going opposite of how I have the big version. Each scoop, instead of it peeling away going up, I have it coming forward, which messes with my mind a little bit because of it's opposite of how the big one is. It really shouldn't matter as far as performance goes, but it just is a little bit weird. Yeah, it'd be nice if I could come up with a way to lock all of those scoops together, but there's absolutely no way that I can conceive of doing that without having a furling shaft going the whole way through it like the big version. And, you know, for this little model, it's just not practical. So, Mark, each one has its own furling pin. You see each scoop itself in this little model has its own furling pin or a locking pin. I don't know how to do it in this little model any other way, because we've got to reduce the number of moving parts. We've got to simplify it. We have to keep this as simple as possible. So when you think about putting this together, you would assemble a scoop pair just like this. It would be a top, a bottom, the little spindle like lock on the top, or the circle, and the gear on the bottom. So, you know, there's a number of parts that would have to be assembled. I can't send it through the mail fully assembled, because then, well, we could, but boy, for us to assemble everything, then we would need a much larger box. It would risk getting crushed or getting hurt. By keeping all the components flat, we can ship it in a box, much smaller box, keep it flat, keep our what we have to do down to a minimum. And I think if I make several good assembly videos, you could really have this assembled inside of 15-20 minutes, half hour max. It wouldn't be much to put this little model together to have your working little Harmony prototype. I don't know. I think the kit makes more sense too, Frederick, but that's why I'm modeling it here in 3D, to see, you know, as I put it together, what makes sense. That little locking pin, or lock, it's really not a pin, but that little lock is what would keep each individual scoop set at whatever angle you want. I'd love to eliminate that, because it's a pain in the butt, that piece, but then I don't know how, you know, to let you guys mess with the furling. And if I take that ability away and it's just stuck in an open position, then I don't know. What do you think? Do you think people would go for it if it's, you assemble it, you put it together, and it's just stuck 100% opened? I mean, you can't change it. You can't even close it up to take it home. Like if you're out on a, you know, having a lunch or something, and you want to throw it in your car, the whole thing's going to be open like this. If I take away that furling capability and just fix those, you know, those square scoop separators, or the scoop support. What did I call it? Scoop support shaft. If I fix those scoop support shafts, and you've just got a square hole up here that you would put it in, put a drop of super glue on, I mean, man, that really simplifies the build process. You'd be done assembling it and building it, and it would just be stuck in a fully open position like this. Stick your central shaft down through it, get in there and put a little dot of glue every place where you can get your little nozzle in there. Put a little bit of glue, so the shaft would be probably like maybe a wooden dowel rod, and that would be fixed to the it would be fixed to all of the scoop supports. The scoops themselves would be stuck fully opened. I mean, it would make for a very nice little rigid unit. but it would be stuck like this. It would be stuck open. And it certainly decomplicates it, because then I don't have to worry about doing the gearing on the bottom. I don't have to worry about this little switch thingy. I don't have to worry about complicating the build by explaining how to put the little switch in and do all that. Maybe I offer that as a different model, the simplified model. Model number 1 is you put it together, you have minimal assembly, it goes together, you just have it glued in its fully open state, and that's it. It just stays fully open. It can't furl, it can't close. And Model 2 would be the more complex, more expensive one. I don't know. What do you guys think about that? Could we have 2 pins running top to the bottom? Yeah, Mark, I thought about that, but when you get into the permutations, like, okay, going off of what you're saying, that was the very, very first thing I thought of. But if you figure, okay, you drill a hole down through right now, I don't even see where you would actually drill through, because there's no location to put a pin that's going to grab them all. Like if I drilled down, if you can see my cursor, straight through here, for instance, I'm not going to catch all 4 scoops on, I'm going to catch scoop number 1, not scoop number 2, not scoop number 3, and not scoop number 4. Like there's so many problems with drilling a hole down through there, and if I would drill a bunch of holes, and it'd be like putting a Rubik's Cube together, you'd be trying to figure out at what position you have to have them to match up with this hole and that hole. It would be like a nightmare. It's sort of, yeah, wow, there's like the only one place that you could drill down through that would catch all of them would be like right here, I think. And it would be a very, be on the edge of some of the scoops, which I don't know how that would go, because then we'd be getting into the possible hitting the sidewall and stuff like that. So you could drill a hole down through right here and put a very thin pin down through, but it would only be like, I don't know. Boy, oh boy. They're all moving together right now because I have them all 4 highlighted. Yeah, see, as soon as you start closing, now the top one and the bottom one, there's not enough material there to catch them. So now you'd lose those 2, and that single pin wouldn't work for anything but a fully open state there. There's just no real easy solution. Make the top and bottom cross-shaped. Make the top and bottom top and bottom pin cross-shaped? I'm not sure what what you're implying to make cross-shaped there. Yeah, I'm afraid the mountings. Oh, okay. It still makes things very complicated, though. It wasn't that I didn't have mounting material to plug into for the scoop support or the oval-shaped piece. It's that the scoops themselves are in odd positions that a pin straight down through isn't going to really hit things properly. You know, like even if we're out here, as soon as I turn on the highlighting for all of them, even if I was out here, you're not catching the bottom scoop here. And if I'm here, then I'm not catching the top scoop or the bottom scoop. So it's like I'm only catching the middle two. The whole pinning idea, I had played with it early on a couple days ago, and I just didn't like the way that complicates things so very much. So, I don't know. What do you guys think? There's 10 of you on here. I feel like it very much complicates the design to give people these little locking mechanisms to allow you to go in and out with it. When it's out, you can spin the, or not spin, but you can rotate each individual scoop however you want. You wouldn't be able to do that very cleanly, though, because you'd be kind of guessing that you've got the scoops all open to the same angle. It would... Ooh. In the big model, it's so nice because the furling shaft and the furling gears, when they're all lined up and in sync, it takes care of everything seamlessly. I mean, the whole thing just opens and closes like a dream. Christoph, that's kind of what I'm hoping to prove here, but until we get time in a wind tunnel and the ability to test it all, it's hard to say if it will be more efficient. There has been data coming back from an overseas university that built a small replica. They 3D printed a small replica of Harmony, put it in their wind tunnel, and tested it. And if you join the Facebook group, you'll see that they came back saying that the efficiency was phenomenal. It was, in the one set of data they sent back, it was 50% efficient in like 3 and 4 meter per second wind. So, I mean, that's unheard of in vertical axis wind turbines. Most of them are like 16% efficient. But until I can build a unit that I can properly test, I can't get behind that data. You know, who knows? They could have screwed it up. They could have had the test equipment set up wrong. So that's why I was going the route of trying to get the data from the larger white model. Have you seen those videos where I took it outside and was doing some outdoor testing? The wind in our area is just absolutely horrible, though, so I can't really get good data out live in the field. Further complicating things is having a proper charge controller, generator, all that crap takes a very intricate pairing, I will say, of the generator and charge controller, and I didn't have that. Yeah, I didn't have the right generator to charge controller pairing. The charge controller itself needs to have algorithms put in it for how much it engages at certain wind speeds, and the one I finally got, ordered the key, finally got the key from China, it only gives like 5 or 6 positions where you can program in at this voltage draw this many amps. At this voltage, draw this many amps. So it's very frustrating because I thought this stuff would be more plug and play, where I could just get a charge controller, put in my power curve, and be done with it. But you've got to have the right type of generator that the voltage range matches your expected RPM range. Vertical axis wind turbines have a very large RPM range. They'll operate like in a RPM range that's 3 times larger than a horizontal axis wind turbine. So that complicates things, because then you start dealing with over voltaging and all kinds of crap. So I was like, man, this is going to be insanely expensive to do it on the big one. So I thought, fine, how could I get funding and do something smaller scale? And that's where I was like coming up with the idea of doing a Kickstarter here with a small model that will work to show you guys not only the principles behind how Harmony works, but let people use it as a functional test bed or a minimum viable product, while at the same time generating funds for the startup. But even this is proving to be challenging, because now I'm coming up with, well, do you assemble it and it's just stuck in a fully open position? And I think that's probably going to be the simplest thing. Just have it stuck in a fully open position and be done with it. If you buy another wind turbine from anywhere, it's always going to be, at least for a small model, fully opened. And I don't know that I should look at that as a negative or a detraction. It is what it is. To give everyone the capability of, pulling this little pin out, changing the furling state, and closing that pin, that's like for really high-end, fine, super detail-oriented testing that someone might do in a miniature wind tunnel. Someone like myself will need that capability, but I don't know that it's necessary for the general public to have that. I'm starting to think it just overcomplicates the build. Yeah, Frederick, I agree. I'm someone who likes to just get in there, build it, get your hands dirty. I may need, for my testing, for miniaturizing things and testing it in a wind tunnel and stuff like that, a model like this with all these little locking mechanisms. But I'm thinking, for people just to have it, just to put it together, I don't think it's going to be worth it. I don't think anyone's going to care to have that complicated of a model, honestly. So it would definitely simplify this build. Massively simplify this build if you've got just a few pieces to put together. Little dot of glue here, little dot of glue there. Right, Mark, I understand, but this is for the Kickstarter, for the small model. I don't think it's practical to be able to show that. I think, honestly, that's like, even even if I put these sliding locks and stuff in it, it's not going to be able to do it automatically in the small version anyway. You know, it never was something that was going to be spring-loaded or centrifugally activated, you know, it was always going to be an electronic control, which is going to require a worm gear, a worm wheel, to translate the power from a stepper motor onto that furling shaft, and then the furling gears translate to articulating the scoops. But that can only happen in a much larger model. When you start getting down to miniature size like this, it'd be crazy to build those little models with furling tubes, furling gears, actuating, furling mechanisms working. I mean, that's like, there's no way you could do that kit for any amount of money that would be worth it. No one's going to want to pay more. I'm even worried that they're not going to want to pay $100 for this little guy to produce 10 watts of power. And, you know, I think if we can generate like 10 watts of power, we can have a reasonably good Kickstarter, because then we could market it as being able to charge small USB devices to show the principles behind it. But you have to think, what's the goal of the Kickstarter? The goal of the Kickstarter is to raise funds for the startup, for creating more, so that I can move on to the larger goals of testing, certifying the larger units, and then starting low volume production, eventually moving into higher volume production with the larger units. And we've got to generate funds. Funds are the key to that. You know, I need to get out of my full-time job, and none of that happens if I'm just rinky-dink toying around and I get only 100 orders or something like that. We need thousands of orders. $100 a pop, 10,000 orders equals $1 million. You know, if we want to do a $2 or $3 million Kickstarter to get some really good funds, you're talking upwards of 30,000 units need to be sold. It's a tall order. I need to keep it simple. I need to keep it lean. I need to keep it functional and easy. And that's where I think overcomplicating it's going to shoot us in the foot in the end, because we're only going to get 30 people that want something that complicated. I mean, Christoph, yes, I could sell the 3D printed files, but I think that's going to really shoot us in the foot. I don't think we'd have more than 1,000 or 2,000 people that would get in behind the Kickstarter at that point. So, yeah, it just, for that miniature version, to expect people to, number one, print it, then assemble it and put it together, I think that would be shooting the Kickstarter in the foot, because it wouldn't, making sure I'm not running over the cat here, it wouldn't have enough appeal to the general public to get them excited, to really go viral. When you look at the really highly successful Kickstarters, they had a product that Joe user out there just purchased for a set amount of money, got it, and could use it. You know, maybe some assembly required, but certainly not like, you know, a ton of work. And, oh, by the way, you need your own 3D printer, or you need to outsource this to Xometry.com or IcoMold and get the parts printed and sent to you. It just, to do all of that, there's no way the crowdfunding would succeed. It would just be a minimal, you know, maybe a few $1,000s we'd get from something like that. So, Mark, you're saying not make it fully auto-retracting, but retractable in some way so people can see it's still working in high winds. So, like I've done here with these little locking sliding mechanisms, you're saying you would like to see me keep it that way so that you could set the scoops to be furled at whatever state you wanted them to be. Each scoop in this would be about 12 inches, so that when it's opened like this, you're looking at about 24 inches from here out to here. See, it's like 23.6 inches. So it's about 24 inches wide and then about 24 inches tall. So it would be about 2 feet wide by 2 feet tall when you're looking at it from the side. It's not going to be very big. It's not going to be able to generate a ton of power. You know, something that small, I don't know. It's a little bit scary to me to think how big we would have to go to get 10 or 12 watts of power. It's surprising how much you need in size to really start getting that power. But I think 2 foot wide by 2 feet tall should generate 10 to 12 watts of power in a 6 to 7 meter per second wind. I'm hoping. But I think for the simplicity of the Kickstarter, to make it a success, I think I'm going to have to keep this super simple. And when people assemble it, it'll just be stuck in a fully open state. And I would offer this more expensive kit that would have the ability for people to set the furling state, like an expert kit or something that we could sell for whatever. You know, if the simple kit is $100, maybe the expert kit would be like $150 or something like that. And that way people could get the expert kit where they could change the furling state of the scoops if they wanted to. But they have to understand it would be a more complex build and assembly process. Yeah, right, a fan kit and then the expert kit, Frederick. I kind of think that's the way to go. I really am starting to think that is what we're going to have to do there. Because it's not practical. The way, when I start looking at this, there's no way Joe Millennial user, sorry if I offend anyone with that word, is going to want to put something like this together. I just don't think it's going to be possible. You know, you're only going to have a very small percent of people, maybe 10% of people, that would want something this complicated, that they could change the furling state and test it in different winds. It would only serve the purpose for someone like myself to really get in there and analyze the data in all different kinds of wind speeds. So, yeah, I think I'm gonna name this expert kit. And I think we'll make a basic kit. It's going to simplify things tremendously here. You're not a millennial and grown up, so you can take a no. A no as in I'm gonna make a A more simplified version? Alright, so, boy oh boy, we get rid of a ton of crap if we do... Where are the wind exiting? Where's the wind exiting the scoops? Basic kit is a better name for it. Oh, then the fan kit. Is that what you mean, Frederick? Christoph, you'll have to rephrase that question. When you say where's the wind exiting, have you watched, I think, if I scroll up, I think you said you saw the other videos of the fully, you know, the big white one functioning in the wind, and you've seen the little pink one spinning in the wind, and even the little tiny blue one, if you've watched the videos long ago, or the one, It's Go Time, because I show some clips of the little purple one and the pink one, or the bluish one. It's like a teal, I don't know, greenish blue. I don't even know what color it is. It's greenish. But all of them spin beautifully well. So when you say where's the wind exiting, I don't know. You'd have to look at computational fluid dynamics and model it to see where the wind is exiting the scoops and how it's getting out of the scoops. But I'm not worrying about that part. Not yet. Maybe later down the road I'll worry about that part. Alright, so we're getting rid of the spur gear. We are getting rid of the lock. Getting rid of the lock slot. Porthole. Getting rid of a whole bunch of things. Boy, does that simplify things tremendously. Get rid of that and that. and that, and that. Wow, that really simplifies things. Okay. I like it. Super simple. Easy to glue together. Boom, boom, boom. Yeah, holy cow. It won't get much more simple than this. So if I suppress the complete scoop and you actually see the parts, you'd be looking at, if I hide everything, so you'd have a scoop bottom in your kit, and then you would have the sidewall that you would put in there. That would just be a flat piece of plastic that is 6 inches by, probably someone do the math on that. What is that? What's that equation for circumference? 2 pi r, I think. So that would be in a 1 foot diameter. Yeah, 2 pi r. All right, so if that's 6 inches, circumference would be 37 inches. So I guess it would be about 18 inches. So 6 inches times 18 inches. Not sure why. $1.7 plus 17, 18. Yeah, that is correct. So you'd have a piece that's about 18 inches long by 6 inches tall. Okay, sorry, I was geeking out on the math there. So anyway, you'd have your scoop bottom. You put a few drops of glue in that little crevice, or oh man, my mouse is so bad. I need a new mouse. I should get a new one here. You'd put the sidewall in, and then you would put the scoop top on, a few more dots of super glue, and now your scoop is together. You would then put your support shaft in. I would put another dot or two of glue here, and that one's ready to rock and roll. You rinse and repeat that 8 times, and now you have 8 scoops with their support shaft through them, all ready to go. Super easy, super simple. Then it's just a matter of you would assemble it. Now you would have to have this opened 180 degrees to put your here, I'll show you. Let's make an array. You want to try and keep much the same on the basic kit as the expert kit to help. Yeah, right, Mark, I would be. It is going to be the same tops and bottom scoops. The sidewall material would be the same. Like all of that would be the same. The scoop support shaft would be the same. Definitely, it would reuse all of that stuff. I'm going to unsuppress this and insert a scoop, a bottom, and a top. Make connector of the support. Whoops. Need to put this on the origin, not of the scoop. Sorry for the tediousness of this, guys. Hi, Michael. I am seeing your message. Is the stream coming through still? Okay. Mike, if you're seeing this, maybe just reconnect. Darn it. Okay. Welcome back, Mike. Mark will forgive you for putting caps lock on. Okay. That's that. So the most complicated part of the build will be helping people to understand that when you insert the next scoop pair in, it gets glued into those two holes. When the scoop is done in an opened 180-degree opened fashion like this. That's pretty much it. Each scoop top doubles as the scoop bottom for the next pair above it. I like it. Simple and clean. Do that 4 times and you assemble it. I think I'm going to go downstairs and start printing this version. Yeah, Frederick, we will have IKEA-like instructions to assemble it. I'll do a nice build video, an assembly video. Yeah, maybe include some printed instructions for people so that they can follow along. Keep it simple. But really, it's just a couple things to glue together, and it would go together nicely. It would be rigid, it would be strong. The dowel rod would go right up through the center here. Maybe a 3/8 inch dowel rod. I think that's what, yep, what I have right now. I think that'll work. Hi, Nathaniel. How are you today? I like it. That is so much less complex. Basic kit would be very, very simple. Be interesting to see if you had the helix going one way where each scoop is in front of its pair on the bottom, or if you had it where each was behind, if you'd get any difference in performance. Be interesting to see that. We'll actually get to test that out when we build these small ones. Probably, I'm going to guess that having the wind peel off the top will be more efficient, because if you're pushing the air that's being pushed off of it like flutes on a drill, if you're pushing that towards the ground, I don't think it'll exit as cleanly as pushing it up into the air. So you'd probably want each of the scoops to be in front of the next one as they're opened. So the bottom, starting at the bottom, when they're opened, you would want the next scoops being behind its pair that was below it on the bottom. Yeah, so actually, I think I could throw that together and show people. So we'll call that assembly downdraft. I think the updraft version would actually be the better one. So Okay. There we go. So that is the updraft version. I know you're like, what the heck's the difference between the downdraft version and the updraft version? But it's whether you put it into the whichever two. If we labeled those holes or those square holes A and B, you know, the one to the left versus the one to the right, you'll notice that in the downdraft version, we're in the holes on the right for the upper scoop support, and we're in the holes on the left for the so downdraft, we're in the holes on the right for the top scoop support. For the updraft, we're in the holes on the left for the top scoop support. Conversely, well, however you look at it, whether you're looking at it from the top or bottom, it's always going to be the same. So if I do the updraft version, Christoph, that's called VFD or CFD, computational fluid dynamics, and it's extremely expensive software. Yeah, the computational, the power to compute these things is super, super expensive. There is a program out there that I have been looking at. It's called ANSYS, ANSYS. I haven't downloaded it or bothered with it yet because I'm not sure how complicated it is to use, but it's possible that that software would allow me to take a look at things, but it could be months and months of a learning curve, and I've already got so much experience with doing this CAD work and stuff that and 3D printing that I can very easily have these parts printed and ready to go here in short order. And in the end, a computer model only gets you so far anyway. Practical, real, true testing is really what you need. All right, so if I do create assembly, and we say downdraft array, and create assembly, updraft array, we'd say downdraft. Okay. All right, so that is a downdraft version. I don't know, maybe I have them named backwards, but as this spins, maybe that's the updraft. Maybe I have them named backwards. I don't know. Okay, so that's the one. It's interesting. All right, and then here is the updraft version. Guess it would help if I'd put the make connectors in. Okay. So downdraft version, or I don't know, maybe I'm calling them the wrong thing. Each of the next scoops grabs the wind as it's peeling upwards. Hopefully you can see that. And in what I'm calling the downdraft, yeah, it's peeling downwards. So maybe I've got them labeled wrong. Maybe this one would be really the downdraft. Yeah, it would be pushing the air down probably. So this is the way Harmony, the big white one that I have, is done. And maybe it's kind of interesting to think maybe it's wrong. Maybe I need to switch the way they're doing it, because I feel like pushing that air downward. So I'm going to rename these. Yeah, I feel like this is actually pushing. I don't know if you guys can see that as I spin it, but if you can imagine the wind hitting and being caught by each successive scoop, it will be sort of pushing the air down, I think. I don't know. Maybe it's pushing it up. It's really hard without smoke or something like that, or computational fluid dynamics, to determine what it is doing. But it's opposite from this one. Even though they both spin in the same direction, it will be very interesting to see if they perform differently because of the way the air peels off of the scoops. See, this is the Venturi effect fluid turbine that you're seeing here with the helix, how it spins. That's the same effect as the Venturi effect fluid turbine. And boy, it's really hard to say which one will push the air upwards or downwards as the helix finishes. So, Mark, if you'd take away the top and the bottom of the scoop, and you would just have the back walls, okay? You can imagine just the back walls. As this would spin, the air would be sort of hitting this scoop, this top one, and it'd be getting pushed in a downward direction. Yeah, maybe this one is the downdraft, and I just renamed them for no reason. The air would be hitting, if you can see my mouse, it would be coming in and hitting and then getting pushed downward, because as it overflows the scoop, if you think of it filling up like a cup of water, air is a fluid, and it would get pushed in a downward direction. So, Frederica, you think this one would push the air in an upward direction? I don't know. I'm thinking if you eliminated the upper and lower parts of the scoops and you just had the back walls, as the wind would hit this, it would be deflected downward. And I think this one, as the wind would hit it, it would blow upwards. This is the way I have the white version of harmony. So when it spins, at any given moment, the air is probably being pushed up into the air as it hits and overflows each scoop. If you start by the bottom scoop, air is pushed up. Yeah, you're behind a little bit now because I've moved on to what I named the downdraft, but I actually think I have these named backwards. I should have kept them named what they were. Yeah, I think I've got them named backwards now. We'll rename these. So I think I had them named correctly the first time. Yeah, I think as the air is hitting this, it's going to bleed off and go up at any given moment. Because as the next scoop comes around and hits, it's going to have a propensity to go towards the path of least resistance, which would be the scoop behind it. In other words, the upward swooping. I think the air would give an upward swirl as it comes off of this orientation, in which case I would name that the updraft. And this one, it almost looks wrong for my mind to see this one because it's opposite of how I have the white one down the basement, the white residential size prototype. It's hard for me to look at it because it's opposite of that one. It's really strange for me to see this, but I think if the scoops were oriented this way, I think as the wind would hit it, again, path of least resistance, I think it would hit it and it would travel downward each time as it's spinning. I think the air would be pushing down and you'd be getting ground effect, like helicopters have to deal with ground effect air as they're too close to the ground. Their swash plate and the downward draft of their air creates interference because it hits the ground and then smashes the air and it moves outward and stuff. I think the ground effect as it's pushing, as harmony is spinning here, would create some kind of interference. Whether that would be beneficial or not remains to be tested. But yeah, it's kind of interesting thinking about it. Whether you want that air peeling off towards the upward, skyward, or whether you want that air peeling off downward. So do both. We'll make both and see if there's a difference. If you get a noticeable change in the performance just by which way the scoops are oriented, because we could certainly use that to our advantage then when making the larger residential sized. But it just deals with how you have the scoops glued into the scoop support. Very interesting. I knew that discrepancy existed, but I never really analyzed it in so much as which way the wind would peel off of it as it's spinning. You know, because these scoops instantly get filled up by the wind hitting it, and then the fluid dynamics, just like water, as soon as that scoop is full, it has to go somewhere, and it wants to go to the path of least resistance. Yeah, very interesting. Okay, so I think this would be the basic kit. And I believe that is a really, really simple part to print. It's really, I don't even need the support top or bottom. It's just a scoop top, a scoop bottom. If I suppress this, a scoop top, a scoop bottom, a sidewall. The sidewalls will not be printed. They'll just be cut out of thin, 16th inch plastic material, about 18 inches long by 6 inches tall. And then the scoop support shaft, the square scoop support shaft. I really think that's quite a nice, easy little kit. For the basic kit, I think that's actually beautiful. You have 3 components to assemble. 4, I guess, if you count putting the scoop top and the scoop support on the top and bottom. But yeah, not bad. All right, what do you guys think? Ah, what the heck? Oh, I know what I did. Unsuppress. That was scary. Yeah, I think this is the way to go. It's just going to be stuck in an open position. Who cares? You know, any other wind turbine you'd buy for testing purposes, a small unit or something, it's going to be stuck in a fully open state anyway. It's the expert kit that would allow people to play with it if they want, change the furling states, but it's a far more complex build. This basic kit, I like it. Man, it's dead simple. It'll go together quick for people, and it should perform well for them. Yeah, Mark, you're talking about it would be good to see if the updraft or the downdraft would make a difference. I would be very interested in seeing those results as well. So one of the things I struggled with, guys, I was trying to determine whether or not I should have 3 segments for the little test unit or 4, because that also makes a difference in how complicated the build is. It's just one extra set of components. I think we'll be okay with 4 of them, so I'm going to keep it 4. But yeah, sorry, I'm yawning. That was one of the things that I was looking at, whether we have 3 of them or 4 of them. But I think it's time to get some scoops printed. Okay. Let's export We're going to call this basic kit. Basic kit scoop bottom. There's the top. Support and support shaft. Okay. They're all exported. Sure, we could do advanced kit, Frederick. I'm fine with naming it whatever. I think it, as friendly as we can make it, the more friendly we can make it, the better, I'll say. I have no problem with that. I'm not even going to bother printing the advanced kit right now because until I determine whether there's an advantage to the updraft or downdraft, that will definitely play into where I have that locking mechanism and all that stuff on the advanced kit. So we're not even going to mess with that. So okay, maybe we do these one at a time. Scoop bottom. Oh, that's why it's like scoop top and see how tiny they are. That was what happened. There we go. Okay, well, we are okay. There we go. These are going to be big pieces. I don't know if I'm going to be able to print. Yeah, because the top and bottom meet up the same way. Wow. I won't be able to print the tops and bottoms together. When we send these off to be printed, that'll be yep. We'll let the printers worry about that. Actually, if we get huge numbers of orders, we'll I don't know. We'll worry about that when we come to that. Huge numbers of orders are a good problem. All right, so maybe we can't do all the pieces at once. I do have multiple printers, but then you get into whether or not the parts are identical enough that they can that they can all fit together. Goodness gracious. Wow. All right. Well, it's okay. We're just printing the prototype. It's going to be quite a bit of that's pretty cool, actually. We're going to do fast, 10%. No support material. Okay. 5 hours. Holy crap. 5 hours? Oh my gosh. Wow. That's crazy. I don't think I need that scoop support to be 1/4 inch thick, especially if I'm not putting parts in it, hiding parts in it. Yeah, it doesn't need to be. There's no point to it being that thick. Not in the basic kit. Should have added another variable in here. That was stupid of me. support thickness. Okay, that's better. Hey, Mark, thank you. Oh my goodness. I hope you didn't waste your whole day watching this. Hopefully you were doing other things and chatting with me here and there. Thank you. Have a good night. Yeah, that was foolish. I should not have used that calculated number so much. Should have actually had a scoop support thickness. Well, that looks a lot better. Okay. That should also reduce the print time by quite a bit.
I don't have a place to sit.
Oh man, he stole your seat.
That's okay. Just share.
Okay, there we go.
Sound like the door.
Okay. Still 5 hours. Holy crap. That is crazy. I can't believe that is that long. Okay, it is what it is. Clearances are going to be a problem too. We're going to have to probably add a little bit of extra space for these squares. Because 3D printing usually ends up being a little tight. I guess I'll let it print just to see what we come up with. Those sidewalls look like they're doubled, so that's good. That'll give them a little bit of strength. Okay. I can't believe that's 5 hours. It's only 10 layers thick. That is crazy.
So detailed or fine?
No,
No. Is it huge?
it is big. Yeah, it's. I can only get half of the components. Man, that's going to be days to print. I'll get one printer doing one and another printer doing another set, and we'll just have to crank through them that way. On my 2 biggest printers, I can probably print but 10 hours of printing for one set, if I catch it right at the change, and then another 10 hours of printing for another set. Times 2 printers going at once, so that's like literally 40 hours of printing if you single thread it all. 40 printer hours of printing. That's crazy. Holy cow. Ugh. All right. Totally worth it, though. Because if we get a working kit, then we send it off to IcoMold or someplace like that to get them to give us a quote on making these en masse. We worry about the mass production later. We just need to make sure we have a working unit that produces the wattage that we're after. All right. Well, guys, I've been almost 3 hours on this live stream, and at this point, I think I'm going to sign off and maybe let this print start down the basement while I call it an evening. Yeah, that's pretty crazy that it's going to take that long. Holy cow. That's okay, though. Me too, Frederick, because this is a learning process for me in much the same way that it is for all of you guys. I know you guys probably think it's like I have the whole thing in my mind already worked out and I know how it's going to perform and everything, but that's not the case. I'm building this as I go, I'm learning as I go, and you're going to see my mistakes as well as my success. So that's the beauty of how this whole process works. It's how I've always done everything when it came to my clean energy technology and research. So thank you for those of you who stuck around. I really appreciate the support. And it made, believe it or not, it made the design, gotta chill, it made the design process a lot more enjoyable. It probably also made me, holy cow. It probably also made me keep my nose to the grindstone a lot more. Wouldn't you say, hun? Yeah, I think it did. It had the end result of keeping me focused. Well, we can watch Star Trek after I get this print going. Yeah, anyway, I'm going to set this up, and then the other printer that I have, we're going to save that toolpath. This will be BF11. B is my second printer I got, the TiVo Little Monster. And yeah, we'll just leave this named Scoop Bottom, Basic Kit Scoop Bottom, because the other three things will be a scoop top, another top support, and another scoop support shaft. So 3 more components, but the mirror image of them mirrored on the z-axis. So that's that one. And now change to TiVo Tornado. Oh, seriously? Oh no. The TiVo Tornado is a different it's a square. Oh man. Wow, I thought if I can't get this sucker on here, that would suck. Okay. Whoo. There we go. You know what? I think I have to resave the other one because I think that support was halfway into the platform. So this is my C printer, CF. We'll just do 20. Scoop bottom. Yeah. When I saved that the last time, it didn't. Okay. There we go. Part of that scoop support was in the build plate at first. But that's correct now. Alrighty. Okay, ladies and gentlemen, thank you for watching. I'm gonna get these prints kicked off and we'll see how things turn out once I get them glued together. I'm gonna end the live stream now. Thank you for watching and supporting and chatting with me. Follow up with any questions that you guys have and stay tuned. Take care, guys. Have a good night.